Good day, everyone. I am Mr. Garth Reed, Student Ambassador in the University of Technology Jamaica and Mathematics Teacher in Training in the School of Mathematics and Statistics. Today, we'll be looking at a Cape Pure Mathematics Unit 2 question, all right, in Module 3 of the syllabus, which is counting and differential equations, all right. So the topic for today is the first order linear differential equation. And here we have our question which says, find the general solution of the differential equation dy by dx plus y times cot x is equal to sine x. All right. Now, let me just remind you about the general form of a differential equation. All right. Linear differential equation to be exact. So the general form is that if you have dy by dx plus p of x times y equals q of x, all right, that is the general form of a first order linear differential equation. And of course, we need to know what is our integrating factor, all right, normally called mu of x, and that is equal to e to the integral of p of x dx. Now, the general solution of this first order linear differential equation is going to be y times the integrating factor, and that is equal to the integral of the function q multiplied by the integrating factor with respect to x. All right. Now let me just say that p and q can either be functions of x or it can be constants. All right. It can be functions of x or it can be constants. So let us now get into the solution. Let us first identify what is p of x and what is q of x. So if you compare it with the general form on the right-hand side, p of x is going to be cot x, all right? And q of x is what we have on the right-hand side of the differential equation, which is sine x, all right? So in this case, p and q are functions of x. Now let us calculate the integrating factor, mu of x, all right? And we know that it is equal to e to the integral of p of x dx. Now we just stated that p of x is cot, all right? So this cotangent of x dx, all right? Now let us do some integration. So let me come down here and focus on the integral of cot x. All right, that is what we have in the power of the exponential term. So this is going to be equal to cotangent of x is equivalent to cos x, all right, cos x divided by sine x, all right? And we're integrating this with respect to x. Now you ought to know that there's a rule which says if you have the integral of f prime of x divided by the original function, which is f of x dx, then that is going to be equal to ln modulus of the denominator, f of x, plus the arbitrary constant of integration c. So let us look at it in this case. We have the integral of cos over sine. Now the derivative of sine is actually cos, right? So it fits the rule here. We can now apply this rule, right? So this is equal to the natural logarithm modulus of sine x, all right, plus c, of course. Good. Let us now substitute this into the integrating factor mu, all right? So we know that mu of x is equal to e to the integral of cot x, and we have just calculated that to be ln absolute value of sine x. All right, I'm not going to write the plus c here. This is not where we write the plus c. All right, so the integrating factor is e to the ln of sine x, the absolute value of sine x. all right? And there's another law, all right, in algebra, which says e to the ln of f of x is equal to f of x, all right? So with that being said, e to the ln absolute value of sine x is equal to the absolute value of sine x, all right? And the absolute value of sine x is just equal to plus or minus sine x. How do we know this? If you recall what you know from the modulus function, let's say I have the modulus of f of x, then that is going to be equal to the positive of the function, all right? That is if the function is greater than or equal to 0, and it is also equal to negative of the function, and that is when the function is less than 0, all right? So the absolute value of sine x is going to be equal to sine x when sine x is greater than or equal to 0, and negative sine x when sine x is less than 0. So what we really have is that the integrating factor mu is equal to plus or minus sine x. All right, that's what we have. So remember now that the general solution, which is what we're trying to find, all right, the general solution is what? Y multiplied by mu, and that is going to be equal to the integral of q multiplied by mu. All right, that is the general solution. Let us now substitute what we know into this equation. So we have y multiplied by the integrating factor, which is plus or minus sine x. Now you can just choose one of them. All right, you can choose either the positive sine x or the negative sine x. Doesn't matter which one you choose. I am going to choose the positive sine x. All right, and that is going to be equal to the integral of q, and we had said that q is equal to sine x, all right, multiplied by, we're going to multiply that now by the integrating factor, which we stated is sine x dx. Good. So on the right hand side, I have the integral of sine x times sine x dx, which is equal to the integral of sine squared of x dx. Okay? Now, you should remember that whenever we're integrating the sine squared of x, we substitute sine squared of x as 1 minus cosine of 2x divided by 2. All right? Divided by 2. That is an identity that we'll be using here. So this is now equal to, we have the integral of sine squared x, so we're substituting sine squared as 1 minus the cosine of 2x over 2. All right, so this is equal to the integral of 1 minus the cosine of 2x, all right, dividing this by 2. And we're integrating that with respect to x. Good. Now, in the integrand here, in the brackets, what we really have is 1 over 2 multiplied by 1 minus the cosine of 2x. 1 over 2 is a constant, and I can take out any constant outside of the integral. So this is now going to be equal to 1 over 2 multiplied by the integral of 1 minus the cosine of 2x dx. All right, I hope you follow that. So let us now integrate the 1 minus cosine 2x with respect to x. All right, so this is now going to be equal to 1 divided by 2, all right, multiplied by the integral of 1 with respect to x is x, minus the integral of the cosine is equal to sine of the same angle. But remember now that we have to divide by the derivative of the angle. Now the derivative of 2x is just 2, so 2 is going to be my denominator there. and I'm going to add my arbitrary constant of integration c. All right, I'm just going to expand the brackets now. So half times x is going to be x divided by 2 minus the sine of 2x, all right, and I'm dividing that by 4. All right, so when you bring the half inside for the second term, you get sine x over 2 times 2, which is 4. All right, plus c, of course. And remember now that my left-hand side is y multiplied by the sine of x. Okay, good. That is what we have. So remember now that my aim is to get y as the subject of the equation here. All right, so I can now say that therefore y is going to be equal to, in order to get y by itself on the left-hand side, I'm going to divide both sides of the equation by sine x. All right, so what I now have is, on the right-hand side, I will have a 1 divided by sine x, all right, and multiplying that by x divided by 2, all right, x divided by 2 minus the sine of 2x, and I'm dividing that by 4, dividing that by 4, all right, plus c. Okay, that is my general solution for this first order linear differential equation. All right, I hope this video was helpful for you. If it was, please ensure to like this video, subscribe to the channel, and also share this video with your friends. I am Mr. Garth Reed, Student Ambassador in the University of Technology Jamaica and Mathematics Teacher in Training in the School of Mathematics and Statistics. I thank you for joining.